So in the last class we discussed about glycogen. Where are the two organs where glycogen is stored? So where the amount of glycogen is more? So more in muscle because the muscle mass is more. But which of them contributes to blood sugar levels? Why? Absence of which enzyme? Glucose 6 phosphatase enzyme is not in the muscle. So whatever muscle glycogen is there, it is only for use in the muscles. Liver, on the other hand, will contribute to the blood sugar levels. Now, in von Wieck's disease, there are two types. Can anyone explain what are the two types of glycogen storage diseases? Type 1. There are two types, 1A and 1B. It is related to the function of glucose 6 phosphatase enzyme. You remember? कोई एक बताएगा? Anyone who remembers? Remember? No? Type 1 is deficiency of glucose 6 phosphatase. 2, where is the translocase required? Why is the translocase required? Glucose 6 phosphatase enzyme, please don't talk. I think both of you should sit separately because you disturb the whole class. यहाँ बैठ जाओ तुम यहाँ पे आके. One of you can come. Yeah. So, glucose 6 phosphatase enzyme, the active catalytic part is inside the endoplasmic reticulum. Glucose has to travel from the cytosol. It has to come to inside the glucose 6 phosphate with the help of a translocase. So the first one, 1A, is the deficiency of the enzyme, and the second is the deficiency of the transporter. So coming to the today's lecture, today I will be teaching about glucose 6 Hmp Shunt. So glucose 6 phosphate dehydrogenase deficiency, and we start with a case. This case is given, I have taken from your UG manual. So a 23-year-old male comes to the medical OPD. He has complaints of fever, and this fever is recurring every alternate day. On examination, his spleen was found to be enlarged, and it was suspected that he is suffering from malaria. He was given chloroquine and paracetamol. His thick blood smear was taken, and it was found that there is presence of Plasmodium. So he was given a course of Primaquine. Within 2 days, he returns back to the OPD. Now he is complaining of a specimen of urine which is dark in color. So he is having some kind of hemolysis, because in hemolytic type of picture you will have dark colored urine. Someone is talking here, please don't talk. You can talk outside the class. The sclera is yellow. So yellowish discoloration of skin and sclera means it is jaundice. It is jaundice. So jaundice is yellowish discoloration of skin and sclera. So his serum hemoglobin levels were found to be raised. What are the normal levels? Up to. And when does yellowish discoloration appear? More than 2.4 or 5. So in between the two, what is it called? Hyperbilirubinemia or late. That is for everything. Hyperbilirubinemia means more than the normal levels. For between these two is latent diabetes. Why am I calling diabetes? Latent jaundice. So between 1 to 2.5, it will be subclinical or latent jaundice. So this person is having frank jaundice. His serum ALT levels are normal. Hemoglobin is slightly on the lower side, and he had to be transfused some blood. Now these are the questions which at the end of the class we will understand. One of them is, what was the cause of recurrence of the episodes of chills and rigors? When does hemoglobin appear in urine? Which drug is most likely to cause the symptoms which are observed? What type of jaundice the patient is suffering from? What type? Hemolytic. What are the other investigations which may be required? And what do you advise to the patient before discharge? So the basis of this patient's picture is actually a shunt, which is called as Hmp Shunt. So why is it called a shunt? It is called a shunt because it is very integrately linked to glycolysis. So this is the fate of glucose in various ways. It will. So one of the pathway is pentose phosphate pathway, and it is linked to glycolysis because the end products, they are there in glycolysis, and the starting material also can come from glycolysis. So it is something. Let me just. This is how it is a shunt. Because glucose 6-phosphate, it can enter the alternate pathway, and the various products, they can also rejoin glycolysis. So it is almost like a shunt and has been named so. Now it will depend upon the flux of glucose. If there is less glucose, glycolysis will be functional. But when there is more amount of glucose, then there will be flux which is going to Hmp shunt also. And Hmp shunt has its own function. So all of you know the function. Do you remember the function? What is the function of Hmp shunt? The one who is lying down with his head and is continuously talking, please don't do so. Please don't do so. So what all can be synthesized? There are two main components which are synthesized here. One is NADPH and the other is ribose 5-phosphate. So ribose 5-phosphate will be required for nucleotide biosynthesis, and NADPH has important function in the body. So what are those functions? It is required for synthetic pathways where there is some synthesis. So fatty acid synthesis will require it, cholesterol synthesis will require it. So wherever synthesis is occurring, you require NADPH, not NADH. Okay. Second thing is, it is required for detoxification reaction. So it is required for the reduction of glutathione and also for the monooxygenases to function properly. So it is not functional in all the tissues, only where it is required. So wherever fatty acid biosynthesis will happen, it is required. Wherever in the adipose tissue there is synthesis, it is required there. In the mammary gland is being synthesized, so there it will be required. Wherever steroidogenesis is occurring, that is steroid ring is being formed, there in the adrenals and the intestines it will be required. So it is required at specific places. And what is the difference in the structure of nicotine adenine dinucleotide and NADP? So the basic structure remains the same. And why is it a dinucleotide? Because one nucleotide is this and this is the other nucleotide. So the one to which adenine is added, that ribose will add an additional phosphate here and will form NADP. So it has two nucleotides. To the one in which adenine is added, in the ribose sugar, you will add one more phosphate and you will form NADP. So this again the same thing. This is where phosphate is added. Now what are the uses? The main use of NADPH is as an antioxidant. It is helping in the reduction of glutathione. So how is it getting oxidized? What is glutathione? This all we will be discussing very later. So coming to the reaction, and I am hoping all of you have been taught Hmp shunt. It has not been taught. So it has two phases. The Hmp shunt is divided into two phases, the oxidative and the non-oxidative phase. So oxidative phase means removal of hydrogen is taking place. So what is being generated here? NADPH is being generated. So NADPH will be generated in the oxidative phase, and in the non-oxidative phase there will be formation of various sugars. So one by one we will go through these reactions, and again the same thing I want to highlight, that the first few reactions they are oxidative, and the next many reactions they are non-oxidative. In the first reaction, glucose 6-phosphate is converted into 6-phosphogluconolactone and then further to 6-phosphogluconate by opening of the ring. These are all ring compounds. Glucose is in the form of a ring in our body, not in free form, very small amount in free form, less than 1%. But once the ring is opened, this phosphogluconate is formed, and from this phosphogluconate, one carbon is removed, a 5-carbon ribulose 5-phosphate is formed at the end of the oxidative phase. So here in all these reactions, in the first and the last reaction, if you see, there is formation of NADPH. Okay? In the next phase, this ribulose will be further converted into its epimer and to a aldo sugar of ribulose, that is ribose. And further reactions will take place. So I will explain. But the end product here will be, if you just look at the end products, will be fructose 6-phosphate, 2 molecules, and glyceraldehyde 3-phosphate. So how many molecules of ribulose will be required for that? How many molecules? So 3 molecules of glucose will enter the cycle, 2 of them will be converted to fructose, and 1 to glyceraldehyde 3-phosphate. So this is how it is the overall reaction. So we go to the first step. So the first few steps of pentose phosphate is glucose 6-phosphate. In the presence of this is the regulatory enzyme. The first enzyme of Hmp Shunt is the regulatory enzyme, glucose 6-phosphate dehydrogenase enzyme. And it is a dehydrogenase, that means removal of hydrogen is taking place and the acceptor is NADP. So NADPH is formed. Then the next reaction here, no formation of NADPH, and in the next reaction again there is formation of NADPH and 1 carbon is removed. So it was from a 6-carbon compound, it is forming a 5-carbon sugar, which is a ribulose. Aldo sugar or a keto sugar? Ribulose, a keto sugar. So first a keto sugar is formed, it can be converted to aldo sugar as well. So here I just want to highlight that the ring is opened in this lactonase step. Here the ring will be opened and then onwards it will be an open ring reaction. This particular enzyme, they say, is highly specific for NADP. So it is highly specific, so it will function only when NADP is present. It is a rate controlling enzyme of Hmp Shunt. This I have already explained. The ring opens. I will not explain because I want to finish Hmp Shunt. You can go and read it again. If you have any doubts, you can come. Again, the third step, that is 6-phosphogluconate dehydrogenase. Here what is happening is the first carbon is being moved as carbon dioxide. So from glucose you are getting ribulose. So it is a ribulose sugar. That means it is a keto sugar which you are getting. Again the same thing, you can skip it. So now we come to the non-oxidative part. So you have presented thiamine. I think most of you have talked about that lecture or seen that. इस बच्चे का रूपाली रोल नंबर नोट कर लो. बच्चा अपना रोल नंबर बता दो. What is your roll number? Not to blame you or anything, just your roll number is required. What is your roll number? 110. So actually in the last class there were 2 students who were sleeping, and not only they were sleeping but they were also saying that we would like that the lecture should be only 30 minutes. Acceptable. Lectures are growing and lectures can make you drift to some other word. Fine. But if you want that the lecture should be shorter, that means 30 minutes should be for the student. So we can have something like a flipped classroom. I have given 2 topics to roll number 8 and 121. I hope they are present.
6 and 120.
6 and 121. Okay, both of them are present together. They were sleeping also, side by side. So both of you have prepared something? Very good. So here what I want to highlight in this slide is that for transketolation reaction, they will require thiamine pyrophosphate. Thymine pyrophosphate is active compound. Thymine is active compound. Thymine or vitamin B1. And if you remember, what is the role of transketolase? Is there any diagnostic role? In deficiency, what will you look at?
Transketolase activity coefficient.
In blood, serum, erythrocytes. So RBC transketolase activity is considered to be the gold standard to see the thymine deficiency. Not the levels, because they may vary. But this is the thing which they see. So they take the blood sample and you can actually see the transketolase activity of the RBCs. Okay? With reaction, this is the reaction. This I have already explained. Okay. So the non-oxidative part, here ribulose will first convert into two sugars, so two glucose molecules are required, to xylulose with the help of epimerase, and isomerase, it will form ribose. Now both of these products will then, they will interact, and the enzyme is transketolase. So ribulose is 5 carbon, xylulose is 5 carbon. Both of them will interact, there will be transfer of 2 carbon sugar from xylulose to ribose. So from xylulose to ribose, if you add 2 more carbon, it will form 7 carbon sugar, that is pseudoheptulose. Now what is left of xylulose is a 3 carbon compound. Okay, so this is one of the products of HMP. Now the next reaction will be between pseudoheptulose and glyceraldehyde 3-phosphate. This is 7, this is 3. So pseudoheptulose will give a 3 carbon compound to glyceraldehyde and it will form fructose 6-phosphate. Fructose 6-phosphate will be the first fructose which is formed. What is left? If you remove from 7, you remove 3, what is left is 4. So erythrose will be formed. This erythrose will again react with xylulose. Xylulose, that means one more glucose is required in the reaction. So xylulose will give a 2 carbon compound to erythrose and that will form fructose. And what will be left of xylulose is glyceraldehyde 3-phosphate. I will repeat it again. In the subsequent slides, so that you can just go through the slides and understand. So the first reaction here is xylulose reacting with ribose. Xylulose will be the giving component. So it will give 2 carbon, 2 ribose, pseudoheptulose is formed and glyceraldehyde 3-phosphate is formed. So what is transketolation reaction? In this, a 2 carbon ketol group is transferred. So this is transferred. So from xylulose, it will be transferred to ribose. Reaction is transketolase reaction. And in this reaction, what is required as a coenzyme? What is required as a coenzyme? Thymine pyrophosphate. So TPP is the coenzyme. The next reaction, transaldehydes do not require thymine pyrophosphate. Okay. Here, the removal of 3 carbon or 3 carbon unit is given, which is dihydroxyacetone is removed from one part to the other. Remember, it will go from a keto sugar to a aldo sugar. So from pseudoheptulose, it will go to glyceraldehyde 3-phosphate and fructose will be formed. The next reaction, erythrose and xylulose. Here again xylulose. In the first reaction also xylulose was given 2 carbon compound. Here also the same thing will happen. Xylulose will give 2 carbon compound and 6 carbon compound will be formed and xylulose left will form a 3 carbon glyceraldehyde 3-phosphate. So this way the whole reaction is taking place. Now, how is it linked to the manifestations which we have seen before? Remember, here glucose 6-phosphate dehydrogenase is the regulatory enzyme and it is controlled by its own product, that is NADPH. So it is the ratio of NADPH and NADP which controls. If it is very high ratio, that means enough NADPH is there, body does not require any more shunt, it will be inhibited. If less is there, then it will, the activity of HMP will increase. High carbohydrate that I told you, one fall is there and 2 falls are there. So if there are 2 falls, high glucose flux will lead to some glucose entering the HMP shunt. So have you heard about glutathione before, like in your previous classes? What is glutathione? It is an antioxidant and it is made up of what is it made up of? Is it a protein, is it a carbohydrate, or it is a fat? Protein, peptide. It is a tripeptide. How many peptide bonds are required for viral test to be positive? Will glutathione give it positive? Glutathione should ideally give it positive because it is a tripeptide. But it will not give viral test positive. Reason being, it has a pseudopeptide bond. Can anyone spot the pseudopeptide bond here? Can anyone spot it? So it is a tripeptide in which glycine, cysteine and glutamic acid are there. कौन से वाले रंग का? Pink or orange? This side. Why? Instead of the alpha minus, we have some other. Very good. So instead of the alpha, here the reaction takes place with peptide bond with the alpha amino group. The alpha amino group has to react, but here, or the alpha carboxyl group, here the carboxyl group which is reacting and forming a peptide bond is not alpha. So this is a pseudopeptide bond, and because it is having a pseudopeptide bond, it will not give the viral test positive. So what are the functions? It will easily donate its hydrogen. So the glutathione in this structure, because of cysteine, has a SH group, and this SH group will donate the hydrogen and it will act as a reducer. Okay? So क्या करेगा ये? See, reactive oxygen species are generated in our body in the routine also. In mitochondria, they are being routine generated, and how our bodies fix them with the help of a whole mechanism. कौन सा vitamin of the antioxidant? E mainly fat soluble में और water soluble में C. So they are actually working together. When you read about vitamin C, you will realize they are actually working together. But glutathione has a SH group and it is acting as an antioxidant. And once the SH group is removed from 2 glutathione molecules, they will come together. So they will form a GSSG compound. That means HH has been removed. So now they join together. What is required for the reformation? What is required for the reformation? 2 glutathione molecules on removal of the H, they have joined together. How can you reform them? By reduction. So what is required for reduction? You require NADPH. So NADPH is required for the regeneration of glutathione. So here glutathione peroxidase is there. Do you know that is selenium containing, very commonly asked in the Viva. Reduced glutathione is converted into oxidized glutathione when it is counteracting reactive oxygen species. So it is preventing their further action with the help of hydrogen. So here water is formed in the presence of glutathione peroxidase enzyme. But this will function only when you have certain free SH groups. This oxidized glutathione has to be reduced. The enzyme is glutathione reductase, and the coenzyme required is NADPH. So NADPH is required. So if a RBC in which Hmp shunt is very prevalent, because RBC is utilizing only glucose. So it is utilizing glucose in the form of glycolysis, and it is shunting some of this to Hmp also. Why? Why this shunting is required? What is the function of Hmp? What is the function of Hmp? What is the function of Hmp बताओ? ये अभी तो पढ़ा है. Hmp shunt क्या क्या प्रोड्यूस करता है? Ribose 5-phosphate and NADPH. And what is the function of NADPH? It is a antioxidant. So it is when it is regenerated, that is when oxidized, it has to be reduced. What is required? For glutathione to be regenerated, you require NADPH. And that is a very important component of the antioxidant mechanism which is there in RBCs. So if NADPH is less, there will be a problem. And the problem will be hemolysis. 10% goes to pentose phosphate pathway, and also it prevents the, it keeps hemoglobin in the ferrous state. बच्चा प्लीज कौन कर रहा है ये? बाहर से आ रही है. So glucose 6-phosphate dehydrogenase deficiency, more than 300 variants are known. So more than 300 variants are known, and this particular disorder, it is inheritable X-linked disorder. It is seen commonly in Caucasians who are from Mediterranean countries. So from Egypt, from France, from these Mediterranean countries, it is very prevalent. Now, there is a very interesting fact which is linked to this. A normal person can handle all types of oxidative stress. Whenever we take medications, we are actually using these chemicals to establish some kind of, normalcy in our body. So they are being metabolized in our body, and they are generating reactive oxygen species. But a normal person with a normal capability of producing NADPH can easily cater to this. A person who is deficient, some deficiency is there, like even 50%. What will happen in a normal situation when he is not taking excess of oxidants? He will be fine. But if he is taking certain kinds of drugs or something to eat which is producing more reactive oxygen species, then there will be a problem. And problem is that now you require more NADPH, but the body cannot synthesize that much. So because of the deficiency, then the manifestations will start. So there is a whole list of drugs which, when given, can lead to hemolysis. So these drugs, there are many of them. Actually, I have written only few of them. There are many of them which, given to these persons, they will develop hemolytic type of anemia, and sometimes that is the presenting features, because otherwise they were normal. So only after taking these medications they develop hemolysis, and then it is found that they are suffering from glucose 6-phosphate dehydrogenase deficiency. So this drug, the common one is the anti-malarials. So after giving anti-malarials, if you get this characteristic history that the patient has developed red colored urine, is complaining of red colored urine, that means there has been some hemolytic event. And why this occurs? It occurs because in the RBC membrane and in hemoglobin there are certain changes because of the cross-linking of the SH group. Now the SH group cannot be reverted back to normal because NADPH is not there. So what will happen? This will precipitate the RBC. Inside the RBCs there will be these kinds of precipitates will form on the membrane and inside in the protein. And so these bodies which are formed, they will be going to spleen, and in the spleen will see that this is an abnormal type of hemoglobin. It will take a bite from that. So what is called as bite cells will be. So if you see, clearly it has been, the part of RBC has been removed. So these bite cells, they are more prone to hemolysis. So this is how Hence bodies, that is denatured hemoglobin, and in the spleen the macrophages will remove it and bite cells will form. Then I told you that there are certain food which may also induce. So in drugs, if you remember few of them, that is fine, certain antibiotics, non-steroidal anti-inflammatory drugs and anti-malarials, they can cause this oxygen damage which can precipitate a hemolytic manifestation in glucose 6-phosphate dehydrogenase deficient patient, but also those who eat flour beans. Flour beans in India not commonly consumed, maybe somewhere in northeast or some distant place, but not in the mainstream. These are big beans. If eaten partially cooked or uncooked, they will have a very strong oxidative response. They will produce a lot of reactive oxygen species, and this can also precipitate hemolytic anemia. So that is called as pharism. It is asked in the Viva. What is pharism? It is because of the consumption of uncooked or undercooked fava beans. T6PD deficiency is very, very common. These are the different percentages in which it is there. So it is almost the whole of the map is colored. And what interesting thing they found in population genetics was that these were areas where there is high amount of T6PD deficiency. There is also an overlapping area of malaria endemicity. So wherever malaria is endemic, there is more glucose 6-phosphate dehydrogenase deficiency. And why this is so? Because it is giving a distinct survival benefit. So what it is doing is, because it is deficient, it increased sensitivity to PVAX occurs. The parasite cannot survive very nicely in a G6PD deficient individual. So if there are two individuals, one who is not deficient and the other who is deficient, the one who is more likely to survive in an endemic environment is the one who is deficient. So over the generation, the percentage kept on increasing. So this is something which is interesting and often asked in the Vivas. Coming back to the question. Now you only tell me the answer. So he was giving first chloroquine and later shifted to primaquine. Primaquine is the one which is the culprit among the anti-malarials. So he had primaquine, and within 2 days he started having a dark colored urine. That means there was hemolysis. So what is responsible for the chills and rictus? It is because of the release of the malarial antigens. So malarial antigens, they are released periodically in blood, And because of the release of these antigens, the thermostat which is there in our hypothalamus is set high. So because of the higher temperature, there are changes. Does hemoglobin appear in urine? When will it appear in urine? Whenever hemolysis occurs, there is increase in production of haptoglobin. It is a plasma protein, alpha plasma protein. And whenever it increases, it will try and bind with hemoglobin and will retain hemoglobin because it is a waste of iron that the body is trying to avoid. So it will form a complex and that can be broken down again. But when there is increased amount of hemolysis, then this haptoglobin will not be able to cater for it, and then you will start having hemoglobin in urine. So when there is increased amount, then there will be hemoglobinuria. Okay? So initially, what is the response? Haptoglobin production is increased. Hemopexin भी होता है protein partner hemopexin, haptoglobin, both of them increase. They try to absorb whatever hemoglobin is there free in the blood circulation. And what they cannot absorb, that will be flushed out of the body. So hemoglobinuria will be there. I don't think we have done. We have done. Please tell me 2 line mein. You will write down the gist of the lecture and then tell me if there was any problem with the lecture. Write it down, all of you, so that you know what you have learned today. Dekho, what was the one learning point which you will remember? Write it down. Can be a statement also. Even be a you can write it down here also. Write it down. Anyone who is more comfortable, like one of you is you prepared? You've also prepared? One by one, please, not together. सब लोग लिखो what you learned today. पूरा मत देखो. Just tell me what you have learned today, and is there any problem? पहले तो synthesis होगा. First synthesis will happen. Right? He will explain by shorthand now on board.
Both of them are very much related. It's difficult to do one topic and not do the other. But what I'm saying is both are related.
First you tell about synthesis. Actually, you have to remember the picture. He will explain something like that.